Well, hello again, dear friends. We're going to continue with Module 3, an introduction to confidence intervals. And in this, you will recall that we started out talking about describing and then inferring. We have in this diagram the picture of a population. The population has a mean, a standard deviation, a variance, and a specific number of elements in the population. The difficulty in most cases is that we don't know the mean, and if we don't know the mean, we can't know the standard deviation or the variance, and often we have no idea how many members there are in the population. So it's very difficult to do descriptive statistics on a population when we know nothing about it. So what we do in these cases is we take a sample. And the sample, of course, it's very easy for us to calculate the standard, the mean, the standard deviation, the variance, and we know the number in the sample. Then we use what we have described in the sample to infer values of the mean, the standard deviation, and the variance and number of the population. This is a very interesting process. We have a population, we know nothing about it. We take a sample, and based on the sample, we're able to infer truths about the population. Now, our goal will be to infer facts about the population based on the sample that we've taken. We will want to make our inference with an established level of confidence. Now, I just unleashed a new term on you. It's called confidence. Confidence is the likelihood that you are correct. We will utilize z-scores to develop intervals in which certain phenomena occur. In other words, within this interval or this z-score level, we will have a certain amount of confidence, and it will change as we change those z-score boundaries. The definition of confidence is generally described as a state of being certain that a hypothesis or prediction is correct. How confident do you need to be? The answer depends on the situations. Some situations are not as critical as others. Now, before we get into this, I want to point out to you that you can never be 100% confident, and you can never be 0% confident. Those two extremes are not possible because there's always a likelihood that something else will happen. Now, here's my first hypothesis. I will live through today. Confidence level, I would desire 100%, but 100% is impossible. I would settle with 99.99999999% confidence. This is 999,999,999 out of a billion chances that I will live through today. Now, hypothesis, I will win $1 million today. Well, if I were going to win $1 million, I would be happy to be just 50% confident that this was going to happen. That means 1 out of 2 times. Since a 0 is impossible, my true chances of winning are 1 in a billion, and that's not very likely to happen. Another hypothesis, this strategy will improve production. Perhaps I would be very happy to be 98% confident. That means that 98 out of 100 times it will improve production. 98% confident implies that I am correct 98% of the time, but I will be wrong 2% of the time. Now, some of the confidence levels are fairly common in research. Medicine, 99.99, areas of extreme concern, 99%, production, 98%, education, 95%, non-critical areas, about 90%. Now, we will develop a concept of confidence for these intervals that will help us establish z-score boundaries for them. Now, consider this diagram just a minute. We want to be 90% confident. That means that 90% of our data must lie within some z-score boundaries, and we trap 90% of it in those boundaries. If we do 90%, we want to balance it, and we want our error on each side, and our error is 10%. Now, you notice that I've substituted a new symbol on you, alpha. Alpha equals 10%. Alpha stands for the error. The error is 10%. Now, in this particular case, we have 5% of that error on each side, which means on this side we have alpha over 2, which is 5%, and on that side we have alpha over 2, which is 5%. So our error turns out to be 0.0500 and 0.0500. Now, can we find the z-score for those matters? Certainly we can find the z-score for those matters. It's not very difficult. And we do that by looking at the tables. And our tables, we find that the z-scores are negative 1.645 and 1.645. And I'll point out to you how we got that. We wanted to look for 0.05 error. We find that 0.05 is right in the middle of negative 1.64 and negative 1.65, so we extrapolate it to negative 1.645. Now, the neat thing is that when you do 90% confidence levels, your z-score boundaries forever will be plus or minus 1.645. That's pretty cool. As a matter of fact, if we do our z-score tables one time, here are the confidence levels the z-score scores for confidence levels. These are called the critical value z-scores. 70%, 75, 80, 85, 90, 95, 98, 99. You don't have to go back to the tables and develop those any longer. All you have to do is use them once they've been calculated, and you just take the sheet with you, and you're going to do a 98% confidence level, your confidence interval. Your score is 2.33, and 99% is 2.58. So that's all very well and good. Look at 70% confidence is negative 1.04 and 1.5. I want you to watch something. 70% confidence, 80% confidence, 85, 90, 95, 98. Do you notice that as we raise our confidence, that we expand the interval? The reason I'm showing you this is that if we want 100%, it actually comes to be the entire curve. Everything is involved. So that has no meaning. The higher the level of confidence, the wider the confidence interval, and the lower the confidence level, then the lower the confidence interval. So you're climbing the ladder. You're doing good. You can do this one rung at a time. I have confidence in you. I'm excited about it. You notice my speaking is a little bit better. I got my crowns put in, but I still need a couple of implants. So for a little while, I'm going to have a slight lisp. But forgive me, guys, my dental tragedy is over. Well, thank you for watching this video. We have 4 more to come in this series of Module 3.